Hey there, physics students. Welcome to another episode of Rapid Review for Honors Physics. Today we're talking about the concepts of distance, displacement, scalars, vectors, speed and velocity. We have a lot of topics here today to cover. Mostly vocabulary, partly conceptual, worth thinking about. We started this session with a cartoon in which one character kicks the other character. I'm not a big fan of violence in these videos, but okay, here we are. One character gets kicked again, back to where they started from, and look, there was no change in the location of this character, which is named Odie. I forgot the character's name, sorry. There we go, all right? So what does that mean? Did Odie get moved or not? Did Odie get kicked or not? Let's talk about it. There's two different concepts at play here. One is the distance Odie moves, and one is the displacement of Odie. As you've learned in class, distance is essentially the odometer reading, like how far in space Odie moved, tallying it all up, and displacement was where Odie ended up compared to where Odie started. So that's the difference between distance and displacement. I'm going to comment, I'm going to use one more word, which is position, which we're going to get to soon. Position is where you are compared to some number line. So if I established a number line and I had 0 here, and I had 1 here, and I had 0 and -1, if I had a number line like that, my position would just say where I am on the number line. So in this example, there was no change in position for Odie, and that means Odie's displacement was 0. So remember that change in position means displacement. They are synonymous concepts, okay? Next, we talked about scalars and vectors. So a scalar is a quantity that has no direction, and a vector is a quantity that does, right? So direction, what do we mean by direction? Like that way, or that way, or that way, or that way, or that way, right? So direction in physical space. We live in a three-dimensional space. When we talk about direction, we might struggle to define it in terms of angles and compass directions and stuff, but we're really just talking about that way or that way. So we'll get into how we quantify that, but remember that the concept of a direction means which way you're pointing in 3D space. In this class, we will often shrink things down to just one dimension where we go left and right, and that's the whole world of motion. Or in this class, we might have motion going on a plane and have up and down and left and right. That's two-dimensional, right? So directions in space depend on how many dimensions we're thinking about. In this class, for now, we'll talk about 1 or 2 dimensions. We'll probably stay away from 3, okay? So distance is a scalar quantity, right? Because if I want to see how many miles I covered when I drove from here to New Jersey, not exactly on a straight line, I would have my distance. But what's my displacement? I would have to look at where I started, perhaps here in Westford, Massachusetts, and some town in New Jersey, and I would find out what the direction was, probably use compass directions, and the straight line distance. So that would be the displacement. Okay? I will not get deeply into this example. It's a good example, but I'm not a fan of this picture because it's trying to show how you get from one place to another. So here's town A and town B, and you go straight line distance, and that's both the distance and displacement if you are talking about going in a straight line. But the picture says, well, if you go over the hill and you take a meandering route, wouldn't you have a different distance traveled? And yes, you would. I'm going to leave it at that. This picture has some flaws. If there's things that bug you about it, don't worry about it, because it's not really north-south, up and down, even though the compass rose suggests that. Likewise, this is a picture that sort of mixes a bunch of concepts. I think what they're trying to say is I'm looking at north, east, south, and west, and I'm looking down on a map, so I wouldn't really draw the school or Tim that way. They would look differently. I'd be looking at the roof of the school, and I'd be looking at the top of Tim's head. So important part of this, though, is that the displacement is this hypotenuse distance, right, plus its direction, up and to the right, sort of. And then the distance is how many steps, count the steps, and you can report that in terms of steps or feet or whatever, or meters or whatever you want. It looks like in here, it's 7 meters of distance, 5 meters up and to the right on displacement. Up and to the right, northeastish. We're going to be a little more specific later on that, but that's good enough for now. Okay, so if I walk in the classroom here or here in the studio at Westford Community Access Television, I might walk from left to right and cover a certain distance, right? So in order to do that, I would need some kind of a measure. I think maybe next time I might actually put up a number line here, but it's just how far I went along the line, right? So I could have a distance covered, and my displacement would be, let's say I have walked, I will estimate here, let's say I have walked 3 meters, then I would say my displacement was 3 meters that way, okay? So that is the difference between distance and displacement. Next, we define speed and velocity. Just take these definitions literally, average speed, average velocity. It's just distance over time, and it's displacement over time for velocity, right? So that's how you get that. These are averages. We're going to talk about instantaneous versus average here, too. So what's going on here with average and instantaneous? So average is calculated the way we showed on the previous slide, and instantaneous just means what you think it does, like how fast I'm going at a given time. So if I'm driving from here to New Jersey at 2 p.m., maybe that at that instant in time, maybe I'm going 65 miles per hour or some number of meters per second. That's the instantaneous speed. And if I average it over the whole trip, 200 miles and 4 hours, I would have an average speed. So that's the difference. I think that's enough about that. Let's just summarize. So what we've learned is that they're scalars and vectors. Scalars have a quantity, scalars are quantities that only have a magnitude, whereas vectors have a magnitude and a direction, both. This is a table I'm going to start. You might have a similar table in your notebook where I'm starting to list scalars that I know and am familiar with and vectors that I know and am familiar with. So far, I'm familiar with distance and speed. Those are scalars. And I'm familiar with displacement and velocity as a result of this presentation. Those are vectors because they have a direction. Next, we're going to be talking about graphs of motion, and that's all we have for today's lesson.